Hello, in this video we're going to be talking about the derivative of unique functions, particularly sine and cosine, and some of this speed stuff. Before I just tell you what they are, I want you to kind of like see why they are what they are. So if this is sine, if we think about what's going on with its slope, it's some value that's positive, then its slope is 0, and then its slope is negative, and then its slope is 0 again. So do we know a thing that is like 1, 0, -1, 0? So, I think I've seen that before. And in fact, it's already typed right here. That's cosine. So the derivative of sine ends up being just cosine. What about the derivative of cosine? Well, swap this out with a g, and then let's take a look at what that is. Okay. Well, so that looks like sine just about, but it's not quite matching up. It's upside down. Boom. Now those, oh, do it the other way. Now those match. Ah, cool. So in your notes, write down the derivative of sine ends up being cosine, and the derivative of cosine is negative sine. And that's it. Thanks for watching. Bye-bye. No, I want to do a little bit more with this stuff, so a place to practice it a little bit. And one way we can talk about this is that roller coaster thing that was showing up before. This idea of position, velocity, acceleration, and sometimes they talk about jerk. And the idea is as you take derivatives of these things, you get different stuff. So position is just where we're at. Velocity is similar to speed, so that's how fast the object is going. Acceleration is how much that velocity is changing, and the jerk is how much the acceleration is changing. But oftentimes they don't talk about jerk. And all you're doing is just taking the derivative in order to figure out the thing that we're looking for. So let's do an example. This one, we've got this body in motion. So this is the body's position. We want to know what its velocity and acceleration are. So to find the velocity of it, we just need to take the derivative of the position function. So if you have position, take derivative, you get velocity. So the derivative of this function here, and oh no, ugh, I know how to avoid those crashes, and so that was on me. Find the derivative of the original function. So that is 2 cosine of t. The derivative of cosine is going to be negative sine. So I'm going to turn that plus 3 into a minus 3, taking the negative from right here. And then then we get sine of t. Great. To figure out what the acceleration is at any time t, you need the second derivative of the position, or we can just take the derivative of what we just found right there. So the derivative of cosine, again, is going to be negative sine. So we get negative 2 sine t, plus the derivative of sine is just a cosine. Oh, wait, why not plus? It's minus. Derivative of sine is just a cosine, so we get 3 cosine of t. So that's telling us our velocity and our acceleration at different times. Taking the ideas from the last one, we want to figure out our velocity and speed at different times. So to find our velocity, we just plug in pi over 4 into our velocity equation, which is the derivative of the position function. So we need to plug it into this one right here. Oops. This one right here. So that is going to be 2 cosine of pi over 4 minus 3 sine of pi over 4, which equals the cosine of pi over 4 is the square root of 2 over 2. So this is just the square root of 2. And then the sine of pi over 4 is also the square root of 2 over 2. So minus 3 square roots of 2 over 2. If we wanted to simplify that down a little bit, and I kind of do a little for fun, so that's going to be 2 square roots of 2 over 2 minus 3 square roots of 2 over 2. So we get a negative square root of 2 over 2 is our kind of like simplified version. And the reason I wanted to get to that is to talk about speed. What speed is It's velocity without direction. So velocity tells us if we're going forward or backwards. Speed just tells us how quickly we're going in whatever direction that we're going. So it's just the absolute value of our velocity. So the absolute value of v of pi over 4. Velocity gives us direction. Speed does not. So it is just going to be the positive version of what we just got. So that's the square root of 2 over 2. To find the acceleration, we need to plug into our second derivative of the position function. So we plug in our pi over 4 into that negative mess. Negative 2 times the sine of pi over 4. So that is going to be negative square root of 2. And then negative 3 times that. That's also going to be this again. So this equals negative, let's see, 2 and 3. So negative square root of 5 over 2 over 2 would be our acceleration at pi over 4. So it's going faster in that negative direction. That negative direction is getting more negative. Sure. What I'm going to do to wrap up this problem is to describe the motion of the body, and I've chosen to graph it because it's just easier to talk about it in terms of this graph. So you can see it's starting here at 3. Reminder, that's 3 on the x-axis, so it's gone towards 3. Starting at 3, and it's heading up, but then it's heading back towards the x-axis. So then right here at time 2.159, that's when it's hit the x-axis again, and now it's heading back in this direction until it hits the negative x value of 3.606. And then it bounces back and forth between those times. We can look at its velocity instead. So it starts out where its velocity is positive, but then at that time, at a certain point, it slows down and its velocity starts heading back towards the beginning, because it's starting to turn around and head the other way. So its velocity is decreasing until it starts accelerating again in the other direction. You can also see the change at those different times. So at first, the acceleration is getting more negative, but then here is where our acceleration hits a value of 0. This question, however, was just asking you to talk about it in terms of the motion of like where it is. So you can just say that, hey, it's going between these two x values. That is it for this video about motion, but particularly about the derivative of sine and cosine. And you may be curious about the other trig functions. Those are going to be coming later. So stay tuned for those. But the derivative of sine is cosine. Derivative of cosine is that negative sine thing. Okay. Thanks so much for watching. See ya.